Thanks everyone for joining. Let me pass over to Chua, who is going to share about a totally and a completely on-premise DR solution.
Yes, thanks everyone. Can everyone see my screen?
Yes.
My voice clear enough?
Yeah.
Yes.
Okay, good. Okay, so this is the part one for this disaster recovery totally and completely on-premise DR. Okay, so I purposely choose this picture. Okay, so if you see this picture, it's actually two people, a couple, go for a holiday. Okay, so if you wish so, you must plan properly for your disaster recovery. Otherwise, it's a nightmare for your holiday. Okay.
I thought which picture? I thought your profile picture.
No, it's not my profile picture. Okay, so let's take an overview of the DR. Okay, so this is also the entire thing which we're going to cover for the whole series. So we have the disaster recovery. This DR stands for disaster recovery. It's not doctor. Okay, so for the disaster recovery, the first we look at this one. Okay, we have the within node failure. Okay, then followed by we have a within cluster. Within node means that parts inside the servers got problem, which you need to prepare for it so that it won't bring disaster to you. Okay, then within cluster failure, which means that if for the Azure Stack HCI, we have the cluster, right? So any failure within the cluster, example, the node, okay, the node is the failure of the within the cluster. So we need to prepare for this kind of scenario. And of course, we have to cater of the cluster failure. How about when the time the entire cluster fail? How we can actually cater for this kind of scenario? Then come to the chassis failure. So this chassis failure is not the normal which we can see. Later I will show you. Then come to the rack failure. Rack is the data center, the server rack, okay? And then come to the last is a site failure. Site failure means that the entire data center, okay, your infrastructure site down. That means for the site failure, okay? So this is the overview. So let's take a look.
I can, once I've been deleted the user.
The first one, within the node, okay? So this, as what you can see, is a 4-node server, okay? And we use this 4-node server to build the Azure Stack HCI. And let's say we have the disk inside the 4-node server. And let's say one of the disk fail, okay? So this is the example of the within the node failure, okay? So you will have to think something to actually help yourself to prevent this from become the disaster for you. So for the node failure, the normal scenario we can see is storage disk failure. And for the Azure Stack HCI, we have the cache disk as well, right? So we have to cater the cache disk failure as well. The next one, within cluster. So we have 4 nodes HCI. So example, one of the node fail. This is the example of the within cluster failure. It can be more than one server fail. Okay, so this is the example. So this is a node failure. Then we have the cluster failure. Example here, we have a egg node server, but this egg node is not under one cluster, but it's separated. Okay, so we have the cluster 1, which is built of the 4 nodes Azure Stack HCI. So another cluster 2, another 4 nodes. But let's say one of the cluster fail. Okay, then what you can do to help yourself. Okay, example, cluster failure. We need the VM replica or maybe cluster sets as the method for your disaster recovery. Okay, then we have the chassis failure. So this is something maybe new to you. Okay, actually quite new to me as well. So example, this chassis failure is only happen to those black server. So example, what's the black server? Like HPE, H-Line, EL 8000. So you have a 4-node server built within one chassis. So how this kind of server look like? Let's take a look. So this is how it look like. So it's like quite normal, right? It's just like a box, okay? But this box, in fact, is very big. It's very big size. How many U? I think could be 10 U, 8 or 10 U at least, okay? At least, okay? And this server, if you look at the front, you see, I'm not too sure this is front or for the end, okay? But anyway, this is how it look like. You see, you have the power supply, and then you have the NIC card, and then on top is the node. And another view is like this. You see the node, you can unplug the node out. So this is the example of the one chassis with a 4-node. And if we actually take a look to the individual node, it look like this. The node is look like this. Inside the node have the CPU socket, is one CPU socket, and then have a 1, 2, 3, 4, 5, 6, 12 slot RAM slot. Okay, then should have the hard disk slot as well. I think hard to see here. Okay, so this is how it look like. You also have the PCIe. So it's exactly like a server. Okay, this server is actually plugged into the big chassis. Okay, so if example, you have a few. Oh, hello. Am I still online?
Yes, yes.
Yeah, suddenly it's suddenly disconnected. Do you see me disconnected?
No, no.
No.
Your voice
No.
still there.
Okay,
Yeah,
then
right.
that's good. Okay, so this is the example of chassis failure. So in the view of the 3 chassis with the 12 node server. Okay, example 1 of the chassis fail. So how you can actually help yourself to move to actually prepare those VM to be auto migrated or fill over to the other remaining nodes. Okay. Then we have the scenario like this, rack failure. So in the data center, you see, especially as what we know now, cloud, right? Cloud is actually built of a lot of rack. So this rack inside got a lot of servers. So example, one of the entire rack fail due to the power or due to the network. Okay, so how you can actually fill over those VM to the remaining rack. Okay. So example of this kind of the failure, we have the node failure within the single rack or single multiple rack failure. Okay. Then come to the last is the site failure. So example, you have the data center at Penang, at Selangor, and Johor. So suddenly in your monitor system show that data center at the Selangor down, and then followed by data center at the Johor down. Wow, this is the big disaster. So what can you do with the remaining site? Right? Okay, cool. So maybe I have a very good picture to actually illustrate all these scenario. Okay, you see, this is our server room. So the server room have a lot of rack, and each rack got a lot of server inside. So looking at this one, okay, if the hard disk fail, so this is okay, this denoted by the node or server or host fail. So if the server, this chassis fail, this is a chassis. Then this entire one is called rack. Then if the entire data center down, then this is called site already. Okay, so I hope you from this picture you can understand what I actually illustrate or I described just now. Okay. Before that, any question? No. Okay. Okay, so let's take a quiz question. Which one is not the supported fault domain scenario in the Azure Stack HCI? A, site failure. Then B, chassis. C, rack. D, active directory. So I think this is very easy. So if you listen to what I described just now, so answer is definitely is the active directory failure. So active directory failure is not the fault domains supported by the Azure Stack HCI. Okay. So let's look at more details into the first scenario within the node failure. So we categorize this as a topic 1. So let's take a look at this scenario. So maybe you are quite familiar to this picture, right? Yeah. In our TTT before that, actually I got shown this. This is about the resiliency of the Azure Stack HCI. But we can take this as an example for this node failure. Within the node failure. Okay. So example number 1, you have the 4 node server. Okay, and one of the disks in the server 1 failed. So this categorized under within the node failure. Okay, so followed by this one. Okay, this is the first server and the 4th server. Okay, got each disk failed. So it's also within the node. Within the node. Same thing like this one. Okay, and with this kind of failure, will not bring disaster to you, because Azure Stack HCI already cater the resiliency in the Azure Stack HCI already can help you to prevent from anything happen. Okay, so if anything wrong on this kind of scenario, what you need to do is just to replace the hard disk. Okay, but okay, then this kind of this failure can be cache disk or storage disk. Yeah, so let's look at another scenario. But if you have the 3 disk failure in this cluster, let's say server 1, 2, 3 down at the same time, so this will bring a disaster to you. But this is not under node failure, within the node failure already. This is not categorized under within node failure already. So I put this example to let you know this scenario is not under within node, but it's the cluster failure. Because in this scenario, the cluster down already. Okay. So this is the example to let you know, to categorize, to understand within what is the means by the within node failure. Okay, so these are the within node. So this is not a within node. This is a cluster failure. Okay, not within node failure, but cluster failure. So let's take a look. So within node failure, example, if we have the cache disk fail, I want to. Okay, so you see this picture. So suddenly you have one SSD fail. Okay, so that failure SSD will be detected by the Azure Stack HCI, and then Azure Stack HCI will actually let the remaining SSD to actually communicate and to get all those data, so that it will handle those failure, and then actually will not bring any disaster to you. And that's why you see in we always recommend you need to have at least 2 SSD to do the cache for the cache, right? And even the disk, you should not bring just 1 disk. You need a minimum 4 disks to build the Azure Stack HCI. So all this kind of design is actually for the redundancy purpose, resiliency purpose also. Okay, so so when the time you have the cache disk fail, the remaining cache disk will actually help you to actually handle the data load and to make sure the HA of the Azure Stack HCI is actually running well. Okay, so you won't feel any fear. So let's say I want to now I found that the disk already failed, no matter is the cache disk or is the SSD or is the storage disk failed. So you can actually just to order the hard disk, and then once the hard disk reach to you, then you can follow this step to actually do the recovery. So let's take a look. So this is the Windows Admin Center for the Azure Stack HCI. And once you log in, you see that, oh, got the 2 drive fail. Okay, you go into the disk2 drive, go to the inventory, go down, you see that got 2 disk field. No, you see, lost communication. So if you click in, you will see that the details. So what you can do, but before that, let's take a look for both. So what you can do once you have the disk with you to replace, right? So you can click this retire. Okay, you retire this corrupted one. Okay, same thing with another unit. Also go in and click the retire. Okay, so after retire done, then you take your hard disk, plug into the server. Okay, once you plug into the server, the Azure Stack HCI system will actually auto rebuild, okay, and repair the entire disk for you. So once you go in again, you will see that, yeah, all your drive are healthy. So you don't have any error with those disk failure again. So this is how easy the Azure Stack HCI can help you to repair those disk failure. So within the node failure, actually it's not a very big problem if you handle well and you actually found it in early time and quickly replace the hard disk as soon as possible, right? So it won't bring any disaster. Okay, so within the node, if you cannot get the original disk, example, your original disk for the cache is a 1.2 TB, but now in the market don't have a 1.2 TB already. So the only available is a 1.6 TB. What can you do? Purchase it, okay, and just plug in, like what I showed you just now. So once you plug in, so will the remaining those excessive storage wasted for the cache? Answer is no. No. So you see this picture. This is 1.2. This 1.6 TB. So even this with the 1.6 TB, you plug in the cache. Then for the node with the 1.6 TB, actually the cache size will be bigger. Okay, you see the ratio is different. So for the cache scenario, it won't be wasted. Okay, but for the storage disk, they're different already. So let's say you buy a bigger storage. Okay, so you see this is 10 TB, 10 TB, right? So this is 15 TB. So it's not not balanced compared to the server 1 and server 2. So the excessive one will become the stranded capacity. Will not be used. No? Not all capacity can be used for the storage disk. So there's some difference between the cache and the storage disk. Okay. So any question? So far so good, huh?
Okay.
Okay. So if no question, then come to the quiz time. Which command is needed to repair Azure Stack HCI storage after a failed disk being replaced? The first one, A, new disk repair. B, start disk repair. Or C, initiate disk repair. Or the D, none of above. So I reveal the answer. I believe all of you know also. Answer is none of above. Because, like what I said just now, Azure Stack HCI can auto repair for you. You don't need to do anything. So you just need to actually retire those failed disks. Then after that, you replace it. Then everything will be automated. Okay.
Chua, just want to check with you.
Yeah.
Just now, when you're replacing the disk, the feature is a hardware feature or the actual feature? You know, to recover the disk.
This one, you mean this video? Okay. This
Because
video
I
is
know that nowadays the server, right? They have the when you plug in when you configure RAID, something like that, right? You automatically repair. But this one, your disk is under RAID or no?
No. Okay, under the Azure Stack HCI, those cache disk or storage disk is non-RAID. No, it's
Okay,
not the RAID one. And the this feature is actually is the Windows Admin Center by Microsoft.
Okay.
And everything is automated by Microsoft. Is by Windows, so nothing related to the hardware vendors software. Okay. No, like what you say, you see here, this is Windows Admin Center. Even come to the stack, like I showed you just now. You come to the drive, right? I click this retire. This is also under the Windows Admin Center by Microsoft. Okay, nothing related to the hardware vendor. Okay, so this is how easy it is. So maybe some people cannot believe, oh, it's so easy, can it be? Okay, but it's true. It's really this step needed only. Okay.
Yeah, sorry, just curious, if all the cache disks,
Hello.
yeah, if all the cache disks are all fail, what is going to happen?
If all the cache disk fail, then will down. The storage will down as well.
Gotcha.
Okay.
So at least one cache disk has to survive.
Yes, at least
Gotcha.
at least the remaining one.
Yeah. Thank you.
Okay. So any other question? No, right? So let's look at.
Sorry,
Yeah. Okay.
under
No
the
problem.
Azure, right? So the Azure is something like software kind of thing. So if I'm not mistaken, if you're using the hardware one, right? So if the cache is down, but the system still work, right? Still working, but only thing the performance decrease. But when using the Azure, the cache down, the cache is down, that means the whole system is not working.
Yeah, if both the cache, all the cache down,
Yeah.
then you will have problem. Yes.
Problem or what I mean, like it cannot work or the performance slow?
Not the performance, not the performance. The software defined storage will down. The storage pool will down.
Okay, you mean the whole thing will be down lah, not like hardware one. Hardware type you'll be, because I know that if you're using the hardware feature, if the cache down but the system still work, the OS still work, everything still system still work, but this the performance you decrease. So it's not the same technology lah, different lah, huh?
It's different. Yeah. Okay.
What was the question again?
All the cache disk down. Will the storage
In all the nodes.
Yeah, let's say. Yeah.
Okay.
Because I remember I tested before. If the cache disk you pull out, then you are causing the storage pool down as well.
Yeah, because I also experienced in one of the hardware storage where they're running in the tier with the cache drive and the hard drive, the so-called the normal hard drive. So if all the cache drive fail, right, the hardware fail, then yeah, the storage data service will be down as well. The data still intact, but the storage service will be down. So yeah, since like Microsoft is using software-defined storage and they are using cache, right? If the cache is down, or then yeah, this is similar to other hardware vendor as I know of.
Yeah. So the hardware vendor, what you mentioned is those SAN storage, right?
Yeah, correct. Hardware SAN storage.
Yeah, I believe so. Yes.
Yeah, because we was arguing with not arguing, but we have the case where customer they have very minimal number of cache drive in the system. So unluckily they have two of the cache drive fail at the same time, and the data service just stopped. So we argue, how come we have the RAID in the hard drive system, but the system still shut down? So there's another things we were not aware in a way, like the cache disk if they are all down, right, the data service will be shut down as well. Yeah, so yeah, that's another loophole.
Okay. Okay.
Yeah.
Thanks. Thanks for.
Along the cache down, the services, the services down lah, not the whole system down lah.
The services down means means the system is not serving IOs anymore to the host.
Yeah, because the whole thing down is another story, right? The services down is another story, right?
Yeah, service down means like if you are running the VMware or Hyper-V or anything, need to get the things from storage, right? Storage is not sending any IO to the host layer.
Correct.
Yeah.
So
Okay.
even you have the compute available for you, but without the storage, so your
Right.
VM will not run as well. Yeah.
Right. Even though the controller is running active standby, but it's not serving IO to the host layer at all.
Correct. Correct.
Yeah. Yeah.
Yeah. Okay.
Yeah. Thanks for sharing.
Thanks.
But it's important to know that every node you need to have a minimum of 2 cache drives. All right, that's the supported configuration. So the likelihood of 2 nodes, both cache drives, and each node go down at the same time, right? It's very, very rare. It's essentially, if you want, it's both nodes have gone down, right? From that perspective. All right. So if that scenario happens in a customer environment, then maybe 2 nodes is not enough, right? And or maybe you have faulty hardware, right? In order to get that kind of situation.
Yes, I believe so. Okay.
So don't think that is something like event error log that before the display on the system before the
oh
cache.
Yes, definitely.
Then
Definitely.
I mean, if both cache down, it means that no one monitor the error log lah, right?
Mostly, I believe so.
Yeah.
That's why I say that. Yeah, if you handle properly, so not come to that kind of situation.
Yeah, that's why.
Yeah. So from what we are. Oh, sorry. Yeah.
Yeah, you proceed. Yes.
Yeah. So from what we are using previously, right? What customer supposed to manage in this case? This is actually a very rare situation. So, the thing is like customer need to usually they will have the monitoring system or the storage itself. They will send a notification to customer when the cache disk failure. So in my case previously, it was happening is due to customer was so unlucky that the 2 cache disks actually fail at the same time. Yeah, so they cannot react immediately and they have to wait for 4 hours response time to deliver a drive to customer place to bring up the data service.
Yeah, but
yeah,
I believe,
so hopefully Microsoft will have something similar to notify customer.
Yeah, something I think worth to discuss with each other. Okay,
right.
Let's take a discuss an example from here. Okay, you see, if I have a one disk field, this is storage disk. If this storage disk fail, I bring a disk to replace it, right? Then it will recover back, right? So you won't cause any data loss. Okay, but come to the situation, if this is 2 node, actually this is 2 node, and then each node we have the one disk field. Okay, so this scenario actually is actually referred to this one. Okay, this one we have 4 servers, and then come to sudden 3 servers got the disk field at the same time. Okay, and this will cause the entire storage disk field. Okay, storage disk fields, I believe, maybe Noel, you can correct me. So when it comes to this situation, if you don't have the backup, even after that you get the disk to restore it back, you may have a problem with the data loss.
Yeah.
Am I right, Noel?
Yeah, correct.
Correct, right? Okay, but okay, come to this scenario. Just now we said that both the cache disk fail, right? So when the time cache disk fail, the storage will down. Okay, storage will down. But if you maybe within 2 hours, 3 hours, or 4 hours, you manage to get the cache disk.
Sure, you have 2 nodes, you see. If these 2 cache drives fail in one node, you still have the other node to keep the storage going.
Yeah,
So
let's
in
say
order
both.
for the storage to go offline, you need all the cache in all the nodes to go at the same time. All right.
Yes, yes. Example is all the cache this field already. Okay, all the cache this field. So if you manage to bring the hard disk plug in back, and then just like HCI still can repair, and then I believe your storage still remain. Can I say so, Noel? This is
See,
something.
the data is stored in the capacity drives. It's not stored in the cache.
Yes.
There's nothing
correct.
stored in the cache. All right. The
Mm.
cache is for acceleration, right? It's for IOPS.
Correct.
All right. So from a cache perspective, if you have cache failure, right, it's not, how to say, it's not end of the world. All right. In
Yeah.
fact, you can create Azure ACI without any cache. Right. So like our nested environment.
Mm.
Right. Our nested environment doesn't have any cache, right?
Yep. Correct. It doesn't have.
It works, right?
Noel, can I say that if the cache is down, then maybe
Yeah.
the data is not the latest one because some of the data is still inside the cache but haven't updated to the storage. Can I say that?
Just one for a sec, huh?
This one actually I get from the quite latest from the Microsoft website. I think this is latest. These two picture.
See, these pictures that you have, right? It's not representation of cache or no cache. See, cache is for the purpose of acceleration, is to give you the IOPS. This is how we get that super duper fast millions of IOPS. So when your cache goes down, all right, you don't have the acceleration anymore. You don't have the ability to absorb the IOPS that's coming in. All right, so this particular storage environment will not be very fast at all. Okay, so if you look at our nested environment, right, we don't have cache, correct? But we can run the PowerShell command to create cache in it, right? But we actually don't. We are not doing it yet. The next generation of labs we will, all right, because I think it's important to simulate a scenario of cache and non-cache disk, right? But even without the cache disk, we have a working Azure ACI environment. All right, we can test that out. All right, you can see for yourself.
Yeah.
All right. So Long, you're doing the labs, right, as we speak.
Yeah, right.
Right.
Yeah.
You have a look at the environment. All right.
Yeah.
Probably Chua or Ko can give you the PowerShell command to enumerate the drives. You realize we don't have any cache in the nested environment.
All right.
Yeah, and it works perfectly. It's just that the nested environment will never be used for performance benchmarking. You wouldn't benchmark the nested environment because it will probably be really horrid.
Okay.
Right? But it works. So
All right.
I personally don't think the storage is going to go down, even if all the cache go down. All right. So let's see. We can test that. All right. It's an interesting scenario where all the cache go down, because in our nested environment we don't have any cache, but it works. Right? And the ones that they build, even in the GitHub MS Lab, I believe also don't have specifically defined cache, because the virtual drives, right? How to say, they all defined with the same ID. There is no way in Hyper-V to say this virtual drive is a different ID by default. Right? Because when you use different physical devices, when you run the command, storage spaces direct command to create the storage, it will automatically detect the different types of devices and will assign a different ID to each type of device. Right? And if the fastest type will become cache, and the rest all becomes storage pool. All right. So if you think about it, in the case of a nested environment that we use, because we are using virtual disk for every disk that we use, so actually we don't have cache defined in it. Does that make sense, Chua? You have a look?
Actually, I remember in a very, very long time, when the time you have the 2-unit Dell server with me, right?
Yeah.
I tested the cache. I unplug it, then it was causing the down. But I can't remember what kind of scenario. But I remember I very clear that it's the cache disk I unplugged. But I think
I think
both
you
to
can,
try, both try.
Yeah.
Yeah.
I think this one can be tested, but if like the original configuration has no cache configure, right?
Yes, correct.
Then definitely you'll be running as per normal because it's running on the hard drive with the RAID inside. Yeah.
Yes.
So the scenario here is
It's,
like with
we
the
don't
cache
use
configure
RAID.
and cache
We
down.
don't use RAID. We don't use RAID. So whatever that we define for the volumes and so forth, it will still be working. So you're right. So if we had cache drives defined and all the cache went out on one node, you still have the other node running.
Yeah.
Right. So the remaining node will keep the system going. But
Right.
if there was a situation where all the cache in all the nodes went down, and in the case that the cache drives do affect that particular node, because if let's say in this case, the picture on the left, where you have the two NVMe, although they are not equal in size, both went down. And on the other node, the same thing happened, all the cache drive go down, then the storage will be offline. Right? Doesn't mean that you have lost your data. It's just that there is no cache available, so the storage has gone offline. You have to replace all your cache.
Right. I understand.
Right? Because the data is stored in the capacity, is not stored in the cache. Cache is like a, it's like the hot tier of a storage.
Right.
The data is stored in the cold tier. The cold tier is the capacity tier. All right. So where you see in the diagram in black, right, those disks, right? It could be SSD, by the way, all right? You could be using SSD in that capacity tier, all right? So that's the thing, all right? If you have all of them NVMe, you have no cache, okay? If let's say, for example, all the drives, right? That's what we call an all-flash NVMe or all-flash SSD. We actually have no cache. All the drives are used for capacity. There's actually no cache. So in that scenario, then there is no cache failure that you can define. It will be this is like capacity failure.
Right. Too fast to have cache.
Yeah, you don't need cache in those situations. The HSACI software, when you run it, it will look at all the drives and it say, oh, they're all the same.
Right.
Okay, so we're not going to create the cache for you. Just like when we use the all virtual disks, they're all the same, so we no cache. All right. You actually have to manually define with PowerShell the cache that you want.
Right.
But by default, there'll be no cache.
Right.
Okay. So think of it realistically in that particular manner. So the scenario of all cache drives fail, it will be tantamount to the whole storage going down already, not specific to the cache. Right? Not likely to have cache failure in that manner. Right? So
Okay.
whose question was that?
Oh, I was asking that because I got experience with the storage down because of all the cache down, the 2 drive cache down.
On a single node or on multiple
No,
nodes?
it is a SAN. It is not the HCI system.
Ah, okay.
Yeah, so
Okay.
I just want to understand if this is similar to the behavior is similar to hardware SAN.
SAN is different, you see. SAN is a single box, right? With double controllers. HCI systems are compute and storage plus the what they call the SAN fabric all merged inside a single node and duplicated into a second node. So the
Right.
resiliency of a HCI and resiliency of the SAN is totally different.
Whatever you
Because
can
in the SAN, you have no compute. In the SAN, you don't have the SAN fabric. It's all external. You know what I mean?
Right.
just one of the
Right. So in the SAN, what you have is the storage controllers. You have two storage controllers.
just
Yeah.
to have
All right.
a very
And then you
few
have your drives and your cache.
just
Right. So
want to have
essentially, this picture here may look like a SAN, but this is the inner storage and caching mechanism of a HCI node that has compute hanging off beyond the NVMe connection. In fact, it connects to what we call a HBA, a pass-through HBA.
Mm.
You know what I mean?
Yep. Right.
So it's the inner workings of the SAN, and this is very different from that perspective. And therefore, the resiliency of the storage is also very different.
Mm. Understand.
Yeah.
Thank you. Thank you.
Okay. No worries. Okay. All right.
Thanks.
Keep on going, Chua. Thanks.
Okay. So come to the topic 2 is the within cluster failure. So scenario of within cluster failure is the NOT failure. Okay. So like this one, okay, the entire NOT fail. So with the 4 NOTs Azure HCI set up, one NOT fail will not bring any disaster to you. Okay, even 2 NOT fail also won't bring any disaster to you. So like this one also, okay, this is the NOT failure plus the this failure. So this is the combination, combination of scenario 1, the within NOT and the cluster failure. Okay, so these are actually not failure within the cluster. Okay, and all these 3 scenarios will not bring any disaster to you. So what you need to do is just you need to quickly make sure the failing not actually recover. That means is up and back, and then the data will actually resync back. So, but this one will bring disaster, and this one is categorized as a cluster failure. Okay, like maybe like what you say just now, all the cache this fail, but it's very rare. You see, can be all the cache within the 3 server fail. I think is almost impossible. Okay, but anyway, if there really this happen, then we come to the cluster disaster recovery in the topic 3. Okay, so now is the topic 2. So what I say here, not within cluster failure, but it's the cluster failure. So let's take a look. So when server 1 is in the maintenance, you see it as being down. And when you bring the server 1 back up, it start to resync all its data automatically. You don't need to do anything. Okay, and once you see here, once data is back in sync, all server are shown as up. So this is the we consider it as a server minor error. Server minor error is something like, you see what we categorize as server minor error. Example, power supply failure, then the knockdown, or the network card, okay, or the RDMA card failure. Then although the server is up, but the communication cannot be talk to each other, then it will categorize this as a down as well. Or maybe the RAM failure, right? So all these is considered server minor error. So when the time you have this failure part replaced, and then the server up, everything will be auto repair, auto resync for you. You don't need to do anything. But when we say that as the severe error is which is a serious one, you need to not do the not replacement. Example, the motherboard corrupted, and whatever error which cause you to have to change the knots. So this we categorize as a not replacement error. So when you come to this scenario, what you need to do, okay? The entire knot, the hardware manufacturer change a new one for you, okay? So you have to proceed with the remaining job, right? So what you have to do, let's take a look. Okay. Yeah. Okay, now in the Windows Admin Center, you discover got server error and got drive error. So you click on this server error first. And then from here, you click inventory, you see that, oh, server down. And then the server down, of course, will cause the disk down. And if you go and see the hardware, you see that, oh, the hardware actually bursts. Then you have to call to the hardware warranty, and then they get a new hardware for you to replace. So once you get the hardware replaced, you need to check the RAM, the processor, okay, the disk, everything are actually same as the other nodes. Okay, all the disks are the same, okay, although it's offline, but they are the same quantity, same amount, okay. Then you have to make sure also you install the Hyper-V role and install the failover clustering role, okay. So once you've done this installation, you go to the Windows Admin Center, you remove this down node first, okay. You remove this down. So you don't take this one, remove the drive, okay, just remove the server. Okay, once you remove the server, okay, from here you can see the removing process. Okay, once done, you see that the server number 4 being removed. The next thing, you go to the server again, then you add the new replace server into this cluster. Okay, how to add? Very simple. Just make sure that you search by the server name. Okay, add it. Okay, click the add button. Then all the remaining job, this Azure Stack HCI will handle for you. So that's how easy it is. Right, you see? So that's all. All your server are up. And of course, this I already cut short. When the time you come to this drive, you still will see error. It will take time to resync. But I already cut short. And then now you can see that all the drive are actually back to normal. Okay. So this is how you can actually do the node replacement for this scenario. Any question? Okay, no question. Then come to the quiz time. So after the failure nodes, the PSU being replaced due to the PSU corrupted, just boot up the Windows and the Azure Stack HCI will auto repair and join the node back to the cluster. Is it true or false? Answer is true. Actually, like what I actually explained to you. Okay. So this is about the scenario 2. Any question? If no, then we come to the topic 3, cluster failure. Okay, so let's take a look. Topic 3, yeah. So topic 3 is actually like what we say just now. Like 4 nodes, right? 3 hard disk fail. 4 nodes, right? 3 server nodes fail. And when it comes to this time, this scenario, the entire cluster down already. Okay, so when the time cluster down, then you have to make sure that you have done some preparation before this kind of scenario happen. Otherwise, this will bring disaster to you. Okay, so what kind of the preparation you should do? Let's take a look. Example, VM replica. Okay, so VM replica is one of the way can help you to actually to solve this kind of problem. So VM replica, actually, this video is not illustrate the entire Azure Stack HCI cluster, but it's the single node. But anyway, the concept is the same. So you replicate this cluster, this VM from cluster 1 to another cluster, or even to the single node of Hyper-V server. It also will help you. Okay, just let's take a look. So this is at the site 1. So we have the host called VM host 1. And this VM host 1 have the only one VM running. Okay, so I can actually use that to replicate to another site. But let's take a look at another site. So this is at the site 2, VM host 2. So this site 2 doesn't have any VM running. Okay, but we want to do the replication from the site 1 to the site 2. So at the site 2, I must configure to enable this computer as a replica server. Okay, so using the Kerberos, or if you don't want Kerberos, you can use the HTTPS, but have to configure with the SSL cert. Okay, so this scenario we use the Kerberos. So once you configure the host 2 to as a replica server, right? You go back to the host 1. And then from this VM, no matter how many VM, you have to do this one by one, yeah? Okay, so you have to enable the replication. Okay, then choose the destination. Okay, then choose who is the replica server. Then using Kerberos. Then next again. From here, you can choose the replication interval. 30 seconds, 5 minutes, or 15 minutes. Okay. Then from here, we do the maintain either one unit of the restore point, or you want to have multiple copy. And then this option is for you to send either to send the initial copy over the network or send through the external media. Okay, so I send through the network because actually I'm in the LAN very fast. So start replicating. So you can see the percentage. Okay, and once done, okay, you can see the help, replication help by clicking this view replication help. Okay, it will tell you the status of the replication. Okay, even from the bottom, you see the replication, this one. The bottom also you can see the status. Now you go to the host 2, then you can see that the VM1 is actually replicated there, but it's in the off state. It's the offline mode. If you click here, then at the bottom, you can see that primary server, replica server, and the replication status as well. Okay. Okay, so actually this demo, I saw that we have the capability to actually do the extended replication to the third site, okay, third host. So this is the way from the second host replicate to the third host. But of course, the third host, you also have to enable this computer as a replica server, do the same thing like what we did just now, right? So after the host 3 configure, then you can start to replicate again, do another replication copy to the third server, so that you have double insurance. I can say that. Okay, you see, extend replication. And this extend replication only can be done in the host 2. You cannot choose this option at the host 1, and it's not available. Only available at the host 2. Okay, you choose the destination. Okay, click next. Also choose the same in the replication frequency. And this one you see, just now you can see 30 seconds, right? But now you don't have that option, because that option actually we choose at the first method, from the first site to the second site. So the remaining one, you don't have that option really. So you can choose 5 minutes or 15 minutes. Okay, then you from here you can choose whether you want have to more replicate restore point. Okay, same thing, send over the network. Then once done, click finish. Yep. So this one will show you can extend the replication. Okay, I'm not going to show everything, but this is the concept. It's about the VM replica. So other than the VM replica, another thing which may able to help you, okay, but this able to help you method is called cluster set. Okay, but this cluster set may not 100% is cover for the disaster recovery, which is like unplanned failover. But this cluster set can help you with the planned failover. Okay, so this cluster set, the concept is like you have a few cluster, and then you combine this cluster together, and they are managed by actually a 2 or 3 server or 4 server. We call it management cluster. That management cluster, like you see here, on top you have the management cluster. Okay, and this management cluster will actually manage all these member cluster. Okay, then and this management cluster will actually form using the scale out file share. Okay, this scale out file share is something like, instead of just direct access to the storage, the volume, right? So it used the file share method. So once you have the file share method, it's easy for you to transfer, okay, transfer those VM data from cluster to the cluster. Okay, so this is about the concept of cluster set. So cluster set, you see, this is actually something like I have 1 cluster, then 2 cluster, 3 cluster, combine a lot of cluster. Okay, a loss. So until how many cluster we can combine together, actually Microsoft didn't set the limit. Okay, but so far they tested on the HCI platform with 100 of nodes, no problem. Okay. So in this demo, I'm going to show you about what I have done before. Okay, so as what you can see, I have 2 cluster. Let's take 3. Okay, so I have 2 cluster. So left hand side, cluster number 1 is with the 2 nodes Azure Stack HCI. While with the right hand side is the another cluster built with the 3 nodes Azure Stack HCI. Okay, and then on top, I will have a management cluster. Sorry, it seems like cannot control. Oh, wow. I fast forward a bit. Okay. Right. What happened? Why? I think because of my taskbar actually blocking. I don't know why this slide cannot show in full screen. Okay, never mind. I just see this one. Okay, you see, we have on top, we have the management cluster, and this management cluster will manage these 2 clusters. Okay, then after that, I will instruct the VM at the cluster number 1, line migrate to the cluster number 2. So let's take a look at this demo. Anyway, this demo is in fact is the planned failover. It's not the unplanned. Okay, let's take a look. So as what you can see here, I have cluster number 1 and cluster number 2. Okay, so on top I have the set cluster, which is the management cluster. So cluster number 1, I have 2 nodes. Cluster number 2, I have 3 nodes. And then management cluster, I only have 1 unit. For the demo purpose, I didn't build 2 units, only have 1 unit. And then we see the rows. So we have 1 virtual machines is running on the node 1, in the cluster 1. Well, in the cluster 2, I don't have any virtual machine. Okay. Well, for the management cluster, I also don't have any virtual machine. So virtual machine only available in the cluster 1. So what I'm going to do, I will actually live migrate this VM from the cluster 1 to cluster 2. So you see, I have 2 commands. So I use this move VM, this move cluster set VM. Okay, this will help me to migrate to this CS201 in the cluster number 2. Okay, I will copy it. Okay, I paste it into the PowerShell. And this I'm now running in the cluster management cluster. Okay, then I execute the command. So once done, you will see that the VM actually disappeared from the cluster 1, but you line migrated to the cluster number 2. Okay. So let's double check. We see the settings. Okay, the hard disk actually you see is the scale out file share. And actually it's still at the cluster number 1 right now because I just moved the compute. The compute actually moved to cluster 2, but the storage of all the VM, all the virtual hard disk is still at the cluster 1. So I use this second command to move the storage to the second cluster. Okay, so I execute this PowerShell command, and you can see that it's moving the storage. And once done, I go back again to check the VM. I click the settings. Then you can see that, okay, the path actually changed. Change to a cluster 2. Okay, so this is how we do the line migration of the VM from the cluster 1 to the cluster 2. And this is the plan failover anyway. Any question before we come to the quiz time? Okay, if no question, then let's come to the quiz time. So does Microsoft, okay, this is a statement. Microsoft didn't limit the number of cluster steps to be created. Is it true or false? Answer is true. Okay, so it didn't be limited. Okay, so but tested so far is have 100 actually nodes being tested. So let's come to the summary for today. So today we have covered within node failure, within cluster failure, and also the cluster or the multiple cluster failure. Okay, so any question? Now is I think we are running a little bit late only. Okay, 5 minutes. So any
I got one
question?
question.
Yes.
Just like you mentioned about the management cluster, right?
Yes.
So how to define management cluster? You have to define by yourself, or is automatically defined by some services?
Okay, when the time you build a cluster set, first you need to set up the additional VM. Okay, that additional VM, then we will actually categorize and define that VM to become the cluster management cluster. And that management cluster is on top of the 2 cluster to actually manage them. So how you can actually build them? Actually, unfortunately, is by PowerShell. Right now, I still cannot find any GUI. I think they haven't make it as ready with the GUI yet. So everything built is by PowerShell.
So the management cluster, you mean the VM that you mentioned, is also a clustered setup, right?
Yes, correct. It's a cluster setup. Okay, let's take a look. Look back at the picture, the diagram I showed. Okay, so this is the architecture view. So management cluster is actually recommended. You need to have at least 2 VM. Okay, at least 2 VM. So these 2 VM, the purpose is to provide the redundancy, HA. Okay, but for my testing purpose, I only build with one VM, just like you see just now, right? So not this one. Okay, this one if I put to the, okay, I minimize it first. Then only I can fast forward. Okay, you see here. Initially, actually for defining, I will put 2 nodes because for the HA purpose. But come to the end, I build by the time I build this one, I only have 1 node. I think just now I got mentioned here, you see. I only have one node. Okay, it's still running, it's still able to run, but when the time you come to the production, it's not the recommended settings. It's the way, not the recommended best practice to build. Okay, cool. I hope this I answer your question.
How can you use one node to found a cluster?
Okay. When the time I build, right? Let me think. I also can't.
Yeah, since the Malaysian cluster is also a cluster, right? Then how do you make it only one node? Then how does a cluster service go to up with only one node?
Yes, actually, with the PowerShell, it made possible.
Okay. So you
Yeah.
use the PowerShell to configure a VM become a cluster configuration.
Correct.
So this cluster, this management cluster also need to join to the AD.
Yes, need to join to the AD.
Or
You see?
it has its own AD.
No, actually join to the same set of AD. You see from here?
Okay.
These are the same set.
Okay.
Just like our recommended settings lah. So for all the Azure Stack HCI, normally we will use the version AD. So these also join to the version AD, not to the product.
Okay.
Okay. So yes, I know it's funny and it's a very good question also, Call. So but then that for the testing purpose, yes, it's possible. Just one more.
Okay.
Yeah, sorry, just a quick one, right? Just now there's one slide regarding the NVMe cache. I see the two NVMe drive size different. Is there any impact if we are using the different side of the NVMe cache or normal SSD cache?
Yeah, very good question.
Any
So-
like performance impact or
Okay.
any recommendation kind of thing?
Actually, it's supported. Is not an issue. Just like this picture show, right? So when the time, if you cannot buy the same set of the NVMe, so you buy 1.6, right? So this node will actually have a bigger cache ratio. Okay, so I can say that slightly this one, the capacity, when the time the performance, I can say that is slightly better. Okay, slightly better a bit. But it won't impact the entire Azure Stack HCI.
Okay. Gotcha. Yeah. Thank you.
Okay. So I think is very good, good question, because I found this. I also feel that this is very interesting. So that's why I want to put and share with each other, all of you.
Based on the documentation, there could be slight performance difference because sometimes different cache device sizes could be rated with different performance, right? But the cache must be this write per day, a minimum of 3 and above, right? Versus if you use the SSD or NVMe for capacity purpose, right? So the performance of mixed use, as what many of them commonly refer to it, right, would have a this write per day of a minimum of 3. Okay.
Okay.
By the way, all of this is available on the Microsoft online documentation, right?
Yeah.
Yeah, we
Okay.
see the link drive symmetry considerations at the bottom of the slide.
Yes, actually I could put the reference, right? Yeah.
Yeah.
Correct.
Yeah.
I myself, I cannot see the reference. I don't know why my taskbar is still blocking at the bottom. Okay, so I think thanks everyone. So
Thank you, Chua. Thank you.
yeah,
Great session.
so yeah, stay tuned with us. Okay, so we have another fun, very interesting topic like this one: chassis failure. Okay, rack failure. Okay, site failure as well. Stay tuned.
Thank you.
Thanks, everyone.
All right.
Okay,
Thank
take
you.
care.
Thank you. Very nice.
Okay, bye.
Thanks everyone. I also
Bye.
paste the feedback form into the chat window. Feel free to
Please,
to share
yeah, help
your
us.
feedback to us. All right. Thank you.
Yeah. Thank you. Thank you. Yeah. Right.
Thank you.
Bye.
Good night.
See you next week.
Bye-bye.
Okay, take care. Yep. Bye.